building visualization tools. I'm going to focus particularly on one open source project that I've been working on with Genelia for the past several months, but hope to maybe spark some conversations about what works for other people as well. No pun intended, thank you. So the question is, what should modern data visualization look like? We're at the point where it's no longer really acceptable to just have sort of ad hoc creation of your visualizations. You need to have some sort of, like they were talking about before, reproducibility. You don't just want like random D3 scripts floating around the internet or like random MATLAB functions that you're not sure other people can run. And you want to be able to share your code. So we came up with a few kind of design guidelines for what a tool should look like. The first being that it's web-based. We want to target HTML for two reasons. One being that it's running everywhere and you can share it very easily, and also because of all of these powerful libraries that are out there, such as D3, 3JS, and others that are coming out all the time. And we're trying not to be tied to any one of these. Like I said before, separation of analysis and visualization logic. You don't want to like do your visualization code on the Spark cluster probably, and you don't want to like do any k-means iterations in the browser. Or if you do, you probably have really small data. So it should handle large amounts of data. For a few ways, we want to deal with streams of data, and we also want to have the capability to say, like, I have a visualization, but I don't want to have my entire data set loaded at once. I want to be able to fetch particular parts based on maybe user interaction, playback, other things like this. And this is a scientific audience, so we need to be conscious of this kind of feedback cycle, that you're not just trying to make a pretty picture at the end of the day. And so we built this thing called Lightning. It's a Node.js server running a Postgres database. The data transfer is done via HTTP right now. So you can plug data into it however you can sort of send things across HTTP. We have a Python client and like a web client, but hopefully, like I would love to see an R client for this, JavaScript, other languages. It brings sensible kind of out-of-the-box visualizations that you can permalink to, share with other people, and embed in your website or whatever, or on this server. So this is what the website looks like. The rest of the talk is basically going to be a demo. So this is an iframe. If you're familiar with like IPython notebooks, we have this concept of like sessions. So like each session is a notebook basically where you store all your visualizations. So I can create a new one. There's no data in here, but just by kind of clicking this button, I can put something in, like a line chart. And so you have this graph that shows up. You can kind of annotate it however you like. Using Markdown, you can add more. There's like, I don't know, maybe 10 or so default visualizations that we ship with. This might not be useful to you guys, but you can do maps as well. I don't know if anyone in here has tried to do like these mapping libraries before, but like that's really a pain in the ass if you're trying to do that by hand. And it does this every time you like publish a new visualization to the screen. The JavaScript to run these interactive visualizations is like being compiled on the fly, so that you can have as many libraries really as you want loaded up into the thing, and the data transfer of that isn't an issue. So like, for example, when I added this line plot, it pulled in D3 and created this. And then when I added this map, it pulled in like the topo JSON representation of the United States and published this via WebSocket to the screen. So you can see all the types of visualizations that it ships with here. You can kind of like drill down into each of them. actually see the code on the left that's generating these graphs, and then play around with it on the right. So this is an example of kind of two basic plot types just cobbled together, which is a really nice feature. So every time I hover, you can see this on the left. There's a function, and it fetches data, and it shows it in this line plot. So that's actually going out to a server and fetching down new data. And the nice thing about these editors is that all this code is live. So I'm able to actually edit this if I want. So for example, if I want to change the stroke color, I can just hit Control-Enter, and that went to the server, recompiled all this code, brought it back down, and re-rendered the visualization on the screen. And if I save this, then all of the line plots that I've generated have these attributes on them now. So it's able to kind of on the fly update your styles, and CSS as well. So you could change the thickness or whatever. Yeah, so there's very a tactile way to kind of play around with what you're showing on the screen. So next slide. This is on GitHub. Just to tell you, that, what I just showed you is running on a local server, but it's really easy to host your own on Heroku, as I like to use. So I'm going to do a kind of cooking show thing or something here, where this takes probably 10 minutes to do, maybe 7 minutes. But if you have a lot of images, there's some options to set S3 credentials, but you can just deploy this, and it starts going, and there's not really any configuration at all that you have to do. How do I get back? Whoa. What happened? Oh, there we go. Okay, so this has an API. It's quite simple. Type of chart and the data that you want to put into it. So something like curl can create a visualization. So this is the same server you just saw. I have a session created already. And if I just run a curl command on here, it shows up, right? With those red styles that I just changed, actually. So, yeah. And there's similarly a Python API. That's what this equivalent looks like in Python. I'm going to demo that for you now. So there's a little bit of boilerplate. One is you have to import the library, and then you have to instantiate it. Here, let me. Can you guys see that? All right, cool. And you have to instantiate it. If you weren't hosting it locally, you would just pass in the URL to the server here. But everything works the same after that. So what you do is you need to attach a session to it. I'm going to create a new one. Code Neuro session. So if I look, there's a Code Neuro one here with no data in it. I can make a line plot like I just did before. Editor. And if I do the same thing and I hold on to it, I can do append data and actually send some more data down the pipe, and it'll update for me. Which is nice if you have kind of streaming time series experiments or whatever. So getting a little bit more into it, I have a few scripts written here. First, yeah, I'll show you. This is just a little bit more expanded on what I just did. So it creates a line plot, holds onto the reference, and then every so often it'll just add a new value randomly. So you've got like your stock ticker type thing, and that's like 15 lines of code or whatever once you put it on Heroku. If I can go to the permalink page for this, and like it's still going, and you can send this link around to whoever you want to, and they can see it. So let's see, other examples. We have matrices that we can make similar to matplotlib's heat map, or Seaborn's heat map. So this is a matrix you can kind of move around and zoom in on if you want to. The data is completely random, so it should look like static. So that's the code. Right, this. I can do the same thing, but turn it into a ping file. If I just change that line. So now this is actually an image being rendered to a canvas that I have kind of control over to zoom in and out of. And then finally, this last one is ROI, which you guys saw before, but this is a bit of a bigger example. So I can create an array of point data, x, y coordinates, and then with each one of these points, create a time series, and then just plot that. So what happens when I do this? Takes a second to send everything. But you have this scatter plot where only exactly the data that you are requesting is ever loaded into the client. And so like we have this built-in API to like whatever data you've put into the server to allow you to do this easily and to create visualizations on top of this, kind of using this concept. All right, so let's see what's next. Oh, so here's an example of, I hope it's okay that I put this in the slide. Jeremy made this like a couple days ago using the system. This is like an edge bundled network of the zebrafish. And then the same thing, but overlaid on top of a ping using that image function that I just showed you. So it is to the point where there's some productivity happening. Still a pretty young project, though. Let's see. Oh, yeah, so let's talk about sharing. That's not right. OK. So I don't know if anyone here is familiar with Blocks, the website, blocks.org. So this is kind of like the best way to share data visualizations right now, in my opinion. At least from what I've seen, is that this is coming from a gist on GitHub, and it pulls it in automatically for you. And then it shows you in an iframe like what's happening. So I think this is a fantastic concept, but it's a little bit like, I don't know, the fact that your code is in an HTML file, you have JavaScript and CSS and everything all together here, and it's not like tactile at all, leaves a little bit to be desired. So we have this concept here where you can like preview a remote visualization in our framework just by plugging in the Git repository URL. So I have an example. So this is just a gist with a JavaScript file in it, and like some sample data. And if I copy this gist URL, and then let's see. I'll get back there. What happened? Yeah, so I can plug this GitHub URL in here and hit preview. It'll actually clone that repository, fetch it down, compile this JavaScript, and show you a preview of what's happening over here. And then the cool thing is that all this code on the left is live and editable. So For example, I think I added a comment in here somewhere. Yeah, if I uncomment this line, I can recompile this, and it's like a different background color now. Maybe hard to see, so I can do like. Yeah, and so this is using Three.js. None of the other visualizations were using Three.js before, but since this library is available on NPM, the JavaScript repository, we can just pull it down and like include it. So pretty much whatever front-end libraries you want to use can more or less trivially be added to this process. And so like once I preview it, I can actually import it, give it a name. And now if I go back, you see in this list of types, I have particles here. So, okay. This is an example of like where else these things can live besides just on this website that you saw. So we provide embeddable links to everything. So like this is just a blog post that I made. This graphic is coming straight from the Lightning server. It's still interactive. You can do whatever you want. Same thing here. This also works in IPython with like, the only difference is that when you're instantiating it, you set IPython equal to true. So if I run this, it created a new session for me. Here I'm just making some like random time series data. I can run this block, and like I get this chart out. It's fully interactive. Like I can make an image like I did before, zoom in on the image, whatever. And finally, I can even use like these new plot types that I just added, so like a particle example. Yeah. So particles is a bit contrived because it doesn't really use any data. It just like looks at actually the length of the array that you pass in. But if I like make this array much bigger, you'll see more particles showing up, right? And this is all rendered with WebGL, so it can handle like a lot of stuff. See, yeah. Let's see what else we have. Oh, cooking show. Oh, cool, it worked. So like this URL now is Spooky Goblin. Thank you, Halloween. But like you can just start using this one instead of the local server now. And yeah, that's what I have. So thank you for listening. Do you have any questions?